A star is a massive sphere of scorching gases that produces energy at its core and sends that energy to its surface. All the single stars we see in the night sky are part of the Milky Way galaxy. Although we call these stars local stars, they are far from us, and the nearest of them is about 40,000 billion kilometers away from us. It is estimated that there are more than 200 billion stars in our galaxy, of which about 10,000 can be seen with the naked eye. Shape and variety of stars. In the night sky, we see all the stars as sparkling points of light. Some of them seem brighter than others. From the point of view of the naked eye, there is not much difference in their color, and they are all relatively white, but in fact, the stars are more diverse than they seem. They are found in a wide range of dimensions and temperatures. They are seen in different colors, and their life and life cycle also show wide changes. The distance of the stars. Although all the stars are very far from us except the Sun, their brightness and distance from the Earth vary. How bright a star looks from Earth depends on how far that star is from Earth. Since the stars are so far away from us, gathering information from them is not an easy task. Much of the information we receive from each star is from studying light and other radiation emitted. However, in the case of stars closest to Earth, we can determine their distance by slightly measuring the annual changes in their celestial position. Except for the Sun, the other stars are so far away that we need a special unit to express their distance. This unit is called the light year and is equivalent to the distance light travels in a vacuum during 1 year. 1 light year is approximately equivalent to 9.5 trillion kilometers. 100 bright stars in the night sky are located at distances of 4.4 to 2,500 light-years from Earth. The distance of the stars can be determined in different ways. We use the parallax method to measure relatively close distances of stars. For more distant stars, astronomers have to use more sophisticated indirect methods. Because these indirect methods are less accurate, we have not been able to determine the distances of many of the stars in the sky with certainty, and we have estimated their limits. Here are some of the stars and their distances. Proxima Centauri. Distance from Earth is 4.2 light-years. Barnard. Distance from Earth is 5.9 light-years. Wolf-Rayet. Distance from Earth is 7.8 light-years. Sirius. Distance from Earth is 8.6 light-years. Procyon. Distance from Earth is 11.4 light-years. Dimensions of stars. The stars in the Earth's sky may look like nothing but flashing points of light. But in reality, their size varies over a very wide range. Some of them are so large that our Sun is tiny compared to them, and others are smaller than some of the planets in our system. The little stars are compact neutron stars left behind by the collapse of giant stars. The diameter of these stars is only 25 kilometers. Many of the stars in our galaxy are dwarf stars, some less than 1,000th the size of the Sun. The largest stars, the supergiants, are large enough to hold up to 8 billion suns. By knowing the color and brightness of the star, its dimensions can be determined. Bright blue stars, for example, are smaller than red stars with the same brightness. Because the blue star is hotter than the red star, it needs a lesser level to shine as much as the cooler red star. The Milky Way galaxy contains at least 200 billion stars, 90% of which are in a stable phase of their life cycle. The Sun, an ordinary star in this galaxy, is one of the main filaments classified as a yellow dwarf. It is 1.9 million kilometers in diameter, but billions of years later, when the hydrogen in its core runs out, the star swells to form a red giant, eventually turning into a white dwarf as it loses its output layer. Here are some of the dimensions of the stars that amaze you. White dwarf Sirius B. Sirius B is about the size of the Earth, but its mass is the size of the Sun. Brown dwarf. Brown dwarfs are practically not stars, and they are about the size of Jupiter in the solar system. Red dwarf Proxima Centauri. Red dwarfs are the most common stars in our galaxy and are slightly larger than brown dwarfs. Yellow dwarf Sun. The stars in this category are all main sequence stars and are about the size of the Sun. Aldebaran red giant. The dimensions of this star change from time to time, and the diameter of this star is 44 times the diameter of the Sun. Rigel. The star of the Rigel, the main member of the star of the Orion system, is 75 times the diameter of the Sun. Betelgeuse. This polar superstar is 1,000 times the diameter of the Sun. Life of the stars. All stars begin their life in the form of hot gas spheres formed by the compression of larger clouds of gas and dust under the influence of gravity. But the star's initial mass determines the star's subsequent fate. Stars that form from the smallest masses of gas and dust become relatively small, cool objects known as red dwarfs. These stars are the most common in our galaxy, living for tens of billions of years to thousands of billions of years. Theoretical models say that as the red dwarf age, the temperature and surface brightness of these stars increase, eventually becoming blue dwarfs and white dwarfs. Finally, the stars disappear, and a cold, dead black dwarf emerges. Intermediate stars like the Sun have a shorter lifespan than red dwarfs. However, they live from a few billion to tens of billions of years. These stars swell at the end of their lives and become red giants. The red giant eventually loses its outermost layers to form a planetary nebula. The largest stars have a very short lifespan, ranging from a few million to several hundred million years. Because they have to burn their hydrogen fuel very fast. At the end of their lives, they become red supergiants, who disintegrate in a stunning explosion called a supernova. The nucleus left by the supernova, in proportion to its mass, becomes one of two strange and incredible creatures. Either neutron star or star black hole. The smallest red dwarf stars can live millions of times longer than the largest supergiant stars. Birth of stars. Stars form from large clouds of gas and cold dust called molecular clouds, occupying parts of interstellar space. The process of creating stars inside these clouds can take millions of years. Astronomers estimate that an average of 7 new stars are born each year in the Milky Way, most of which are smaller than the Sun. Supernova. A supernova is a huge explosion that often kills a massive star. A supernova emits such vast amounts of light and matter that it can glow brighter than a galaxy for a short time. In every galaxy, supernovae are categorized as completely rare astronomical events. No supernovae have been seen in our galaxy for centuries. The last time a supernova was seen with the naked eye 20,000 light-years from Earth was in 1604. However, more supernovae have been observed in other galaxies, the closest being a supernova in the Large Magellanic Cloud in 1987. A new and bright supernova may appear in our galaxy at any moment. When a supergiant star explodes, the temperature reaches billions of degrees Celsius. The collision of subatomic particles in these inflammatory conditions leads to the formation of atoms of heavy chemical elements. Some elements, such as gold and lead, form naturally only in supernova explosions. Based on this, it can be said that the main source of all heavy elements in the world of supernovae. Neutron stars. A neutron star is a remnant of a scorching, highly condensed star left over from the collapse of a much larger star, 4 to 8 times heavier than the Sun, during a supernova explosion. Neutron stars are tiny, their diameter is between 10 and 25 kilometers and is about the size of a large city. They are so compact and dense that if we move a particle the size of a grain of sand from there to the ground, it will weigh as much as the largest passenger aircraft. Because neutron stars are so compact, they exert infinitely strong gravity, so the body weight on the surface of a neutron star is 100 billion times that of Earth. Unlike ordinary matter, which is made up of atoms and has a lot of empty space, neutron stars are made up of much denser, more compact matter, most of which are subatomic particles called neutrons. Neutron stars spin around very fast, and the rotation of some of them reaches 700 times per second. The neutron star's gravity is so strong that it pulls its surface, which is 1,000,000 times stronger than steel, forming an almost perfect, smooth sphere. The neutron star of an object is highly dense, spherical, and rotating, with a surface temperature of 600,000 degrees Celsius. This star is so flat that its highest mountains are no more than 5 millimeters high. Neutron stars produce beams of electromagnetic radiation that can be visible light, radio waves, X-rays, or gamma rays. The gravity of a neutron star is so strong that it bends the light emitted from its surface. If you can see one of them up close, you can even see the back of it.